Go to the cloud and share the right screen. Hi, everyone. This is Makayo. I'm doing our final walkthrough for Lab 12. This one, we looked at reclassifying map algebra, raster calculator, and using our slope tool. So all things that we've done before. So let's get it started. I've already downloaded and extracted my data from Canvas. So I'm just gonna start my blank map. As always, make this look like an N if you're doing a desktop, and if you're using a desktop on campus, or if you're using the virtual desktop. If not, let's get started. And then we're asked to add all the layers in our Lab 12 geodatabase. So then let's go to our catalog. Let's right click on databases, add database, and then let's select our Lab 12 geodatabase. I'm going to expand this down, and I can see that we've got T max, T min, solar radiation, precipitation, government ownership, elevation, and dew point. We need to right click and add all of these to our map. All right, cool. So then we can kind of state some features, some hills, coastal areas, but this doesn't really tell us what we want to know. So we're gonna play around with it. First, we need to change our precipitation data from millimeters to inches. So then we're gonna use our raster calculator for that. So then I'm just gonna go to my geoprocessing sidebar right here, and then I'm gonna search for raster calculator. And then just like last week's lab, we're not using the image analyst tool, we're using our spatial analyst tools. So then let's select, actually no, we're given the code block right here. So parentheses, then we're gonna double click on precipitation, and then we click on the multiplication symbol right here. And then we're gonna type in 0.0393701. And then we're gonna close the bracket. I don't know why that's there. Oh, that works. Cool. So you might need to click out of this box to make the error message go away. So that's just something small. We're going to change the output raster to recip converted or conv. And okay, looks good. Let's run it. All right. And we've got our percip conv right here. So let's minimize all of these because we don't need them. Cool. All right, so that was 2 and 2A. On to 3, we're calculating relative humidity. So then we have to first calculate our average daily temperatures using our T min and T max, temperature min and temperature max. So then we're just gonna go back to our geoprocessing tab. We're gonna delete this code block. And then we're gonna do parentheses, T max, plus T min, close the bracket, and then divide it by 2. So then we're going to change our output raster again. This is going to be our average a temp. Oh, yeah, so we've got our T max plus T min divided by 2. Cool, cool, cool. All right. Now on to 4. 4 asks us to use our dew point and temperature to find out the relative humidity. So we can just stay in our raster calculator, and we're given a formula for it. So 100 plus 5 parentheses dew point minus 5 parentheses the temperature, so then our average day temp, close the bracket. All right, so that should work. We're going to change this to real humid. Ooh, close the bracket. Just close the bracket. Yeah, it's not mad at me anymore. So we've got our 100 plus 5 times our dew point minus 5 times our average daily temperature. Let's run it. Ooh, now why did it fail? So then that error is because we don't have one of these, I'm pretty sure. Nope. What's the stitch? Not callable. All right. So then if that happens, we're just gonna do 100 plus 5 times our dew point minus 5. And then our average daily temperature. And then we're gonna make sure we put a multiplier sign right here. And let's run it. All right. So that's something. Yeah, those are the right figures for it. So the instructions are a little bit off. If we just do the 5 parentheses dew point, we get an error. So then I'd recommend 5 times our dew point minus 5 times our average daily temperature. But yeah, so that was 4A. 5 asks us to use the slope tool to find the slope from the elevation data that we were given. So then we're gonna go to our analysis banner, tools, oh my goodness, tools. And we're gonna search for slope. We're not using our 3D analyst tools. We're using our spatial analyst tools. We're gonna input our elevation raster. We can leave all of these as they are, and let's run it. All right, and like always, we got warnings, but those aren't errors. So we can keep on going. So that was 5, now 6. 6, we're gonna be in our reclassify tool. So then let's just get it set up already. Our spatial analyst tools, and we're gonna start with, slope. We're gonna classify slope as 3 classes. So then we don't want manual interval, we want natural breaks, or natural jinks. Okay. Classes can be 3. All right, and cool. So we have our numbers right here. So then we need our slope, but no, we just want our slope between 2 degrees and 15. So we're just going to change this first end to 2. Our new value for this will be 0. Our second start is going to be 2, and then our second end is going to be 15. The new value will be 1 because that's the range that we're looking for. We're going to change that third start to 15 and leave that third end alone. We're going to change that 3 to 0 because that range is not what we're looking for. And reclass slope 1. Yeah, that makes sense. Let's run it. All right, cool. We've got 0 ones, so we know that we're doing that correctly. All right, so then let's keep it going. The next one after slope is going to be our solar radiation. So then let's classify. Solar radiation just needs to be greater than 200 watts. So then we'll do natural breaks. Let's do 2. And okay. So then our first start can stay the same. Our second end will change to 200. Ooh, we'll change to 200. Our new value will be 0. Our second start is going to be 200, and we'll leave the 296 alone. Our new value will be 1. And reclass solo 1. That makes sense to me. Cool. Let's check it out. 0 1. Booyah. All right, on to the next one. So we did solar. Let's do precipitation. So then again, we're not going to be using our old precipitation. We're going to be using our precipitation converted. Let's classify natural janks. We want 3 classes for this one. And all right, so then we want precipitation between 20 to 100 inches. So we'll leave our first start alone. Our first end is going to stay at 20. Our first new value will be 0. Our second start is going to be 20. Our second end will be 100. Our new value will be 1, and then we'll change our 157 into 100 and leave our 353 alone. We'll change the 3 into a 0 and reclass precipitation 1. Yep, that makes sense. Let's run it. 0, 1. Cool. Now we did precipitation. Let's do elevation. Elevation. So then we're gonna use our elevation layer down here. Let's classify it. Natural breaks. We want 3 classes. Sorry. So our elevation, our first end is going to be 200. Our new value for that is going to be 0. Our second start is going to be 200. Our second end is going to be 2000. And our new value will be 1. We'll change our 1700 to 2000 and leave the 4014 alone. Change the 3 to 0. All right. So we've got reclass elevation 1. 11. Let's run it. All right. 0, 1, 0, 1. Good stuff. Last one is our relative humidity. So then I can click the drop down. We've got our real humid right here. Let's classify it. Natural breaks. We only want 2 because we're doing a greater than or less than. So then our relative humidity needs to be greater than 80%. So we'll change our first end to 80, change that 1 to 0, change our second start to 80, leave the 100 alone, and change the 2 to a 1, because this is the range that we are looking for. Reclass real 1. Yep, makes sense. Let's run it. All right. Oh, that looks like a monster or something. Let's do our contents. We've got our 0, 1. All right, cool. So then by the end of step 6, we should have 5 different reclassed layers. And once we have those ready, we can go back to our geoprocessing tab and then click the back button. And then let's search for our raster calculator. And we're going to use our spatial analyst tools. So then we're just going to double click our real reclass real humidity plus our reclassed elevation plus our reclassed precipitation plus reclassed solar plus reclassed slope. So that looks good. I'm gonna change my output raster to the combo underscore raster. And let's run it. Ooh, interesting. So we've got our 0 to 5 values. So just like last week where 4 was our safe value, this week, because we added 5 different rasters together and our safe values were 1, 5 is actually going to be our safe value. So let's change the symbology for this actually, make it a little bit more gradient. That's better. So now we can actually see where the pineapple farms can be built, although they probably shouldn't be built because, you know, it's not company land, but it is what it is. So we've got our combo raster. Now we need to check and see whether the lands that are also good are also part of the state or federal government. So we need to create a raster where our privately owned areas retain their score from step 7, but the government owned areas receive a score of 0. So we're given a code block to use. So let's go to geoprocessing. Let's delete that one. And we'll start with the parentheses. Government ownership is equal to 0, close the bracket, and I'm going to multiply this by the raster created in step 7. We've tried it with step 6, but that's just a error in the instructions. So we need our combo raster, and we can just call this our combo raster 2. So our government ownership is now equal to 0, and then we're using our combo raster to give it a base. So let's check it out. I didn't blow it up. Cool. So actually, let me just deselect all these because we don't need those anymore. All right. So now our 0 is either government or federally owned land. And our 5 is still going to be our safe areas. So let's go to symbology. Let's change our color wheel to, there we go. I really like the green to red. It really shows which areas are suitable really easily. But if you find a color system that works better for you, as always, please use it. But this is where our tool use ends, and we just go to our insert banner, new layout, letterhead, map frame, our Hawaiian Islands. Let's draw our map right here. Ooh, Arc must know this is my last lab for a bit because this is a good extent. Wait, is it? Are we missing an island? We're missing an island. Just kidding. So let's right click, activate, and then let's zoom to layer for our combo raster. There we go, much better. I'm gonna click the back button to get out of our activated map frame, and then I'm just gonna add our usual map stuff. Our north arrow, our scale bar. Yeah, I can go with 140. Move you up though. Perfect. Add a legend. And then we're gonna add a title. This was suitable pineapple farm. Let's make this 28. Yeah, and center it. No. Oh, okay. Works for me. Before we submit, we need to change our legend. So let's go to our contents. Let's double click on combo raster. And then let's change our combo raster to pineapple farm pineapple farm suitability. Yeah. All right. That changes. The value can stay. And then, yeah. So then let's go to share, export layout, JPEG as always. Make sure you remember you save it, and then click on export. But yeah, that is our lab for this week. This is our lab 12. This is our last one. Good job, everyone. ARC and GIS as a whole is not an easy subject to get into. And to reach the end of the class, it's something to really celebrate. It's a lot of hard work to get here. So thank all of you for showing up to class, being ready to learn. It's been a pleasure teaching y'all. Good luck on your finals, and have a good summer.